Hello Internet, this is Andrew aka QuickBrownFox42 here, and I'm here today to talk to you more about Minecraft Redstone. Now, as we discussed in the last video, Minecraft Redstone has two states. It has a powered state and an unpowered state. The powered state on the left can also be represented with a binary 1 or with the states true or high or on. The state on the right can be represented with a binary 0 or the states false or low or off. Now, believe it or not, this may seem kind of insignificant or simple, but this is actually the basis that a lot of our electronic devices, in fact just about all of our digital electronic devices, are based on, just on and off. But obviously there's a lot of steps to building a device from just having these two states. So it takes quite a bit of planning and sort of calculation, and luckily there's a whole branch of mathematics devoted to true or false or on and off states and how we get desired results from a certain input. And this is called Boolean algebra, and although electronics are relatively new, Boolean algebra is about 150 years old. So I'll give you a chance to pause the video while you go and study this entire branch of math. Okay, so that could take a while to learn a branch of algebra, so I'll just go into some basics today. The most basic Boolean function is the not or inverse function, also called a not gate in logic. This function has one input, and the output of the function is simply the opposite of the input. If I have an input over here, you can see that this line over here is not powered. The output over here is powered. So if I add a torch here to power this line, the power, as we saw in the last video, will switch this torch off, and then this line will become unpowered. The next Boolean function is the OR function, or in logic the OR gate. This is very easily accomplished in Minecraft by simply joining two lines of redstone together. The output of the OR function is 1 or high whenever either of the inputs is 1 or high. It is only 0 if both inputs are 0. For instance, with this redstone lamp, if I place a torch next to either of these redstone lines, the lamp will turn on. Another note about the OR gate, the output is also equal to 1 if both of the inputs are 1. The third basic logic gate is called an AND gate. Basically, the output of an AND gate is 1 if and only if all of the inputs are 1. If any of the inputs is 0, then the output will be 0. Now, in Minecraft, we don't really have a true AND gate. However, we can construct one using an OR gate and NOT gates. This is possible due to a law called De Morgan's law. Basically, De Morgan's law states that if you have a function such as A and B is equal to C, you can invert all three values and use the other kind of gate, replacing an AND gate with an OR gate, or vice versa. So back to our original equation, if we have A and B is equal to C, then not A or not B is equal to not C. This sounds a little complicated, but if you look at this function, basically that's all we have right here with this dust and redstone. The output is off because this redstone torch is powered by this line of redstone here. That line of redstone, which is turning the torch off, will be powered by either torch on either side. So if one torch is put down here, even though one torch is turned off, the torch to the output is still powered and therefore off. Also, if we put a torch just here, then the output is still off because the torch going to the output is powered by the other torch and is therefore off. The only way that we can get the lamp that's in the ground to turn on is by putting a torch on both sides, which will turn both redstone torches off, which will turn the line going between them off. and that will turn the torch that leads to the lamp on. So basically, here we have one NOT gate, here we have another NOT gate, and here on our output is our third NOT gate. The two torches connected by the redstone line acts as an OR gate. So effectively, we have implemented an AND gate using 3 NOT gates and 1 OR gate thanks to De Morgan's law. I hope you got all of that because it's not exactly easy to explain. Well, now I know all this stuff about redstone and powering and gates and Boolean algebra, but how do I use this in Minecraft? Well, that depends on what you're trying to build and what you want it to do. For instance, let's pretend I'm playing a game and I'm on a multiplayer server and I have this mountain here, and in it I have sort of a hidden little outpost. Not a huge base, just a place to keep some things and rest. So how can I maybe conceal it from other players? Like, say I don't want to use a door. Like, a door would be kind of easy to see. What can I do to hide it? One idea I might try to help conceal my base's entrance is to use stone blocks connected to sticky pistons. Since stone breaks into cobble when it's mined by a player, stone blocks tend to look more natural. So I have these pistons connected to pressure plates in the ground, but as you can see, the pistons are retracted and the door is open. I would normally like for the pistons to be extended and for the door to be closed, but as you can see, they have to have an on signal in order to be extended, which is only provided when I step on the plates. As you can see, when I step on the plates, it in fact closes the door. So I really want these pistons to do the opposite of what they'd normally do, which means I'm going to use a NOT gate for this. I'm going to put a block of stone down over here and connect a redstone torch to it, which will turn the pistons on. And I'll do the same thing for the other side. Now you can see the door is normally closed, and when I step on the plates, it'll open, which is what I want it to do. So now I can get outside, and when I turn around, it just looks like part of the mountain. Now, let's say we want a way to get back into the base too, since I just had pressure plates here. Well, what I can do is put pressure plates on the other side of the door as well. These pressure plates are one block away from the blocks covering the door when it's closed. And you can see it connects to this redstone line here since it's right next to the pressure plates. And that redstone line is connected to the pressure plates I put in first, making sort of an OR gate since the lines are connected. So using this OR gate, this torch will be turned off if either set of pressure plates is stepped on. So you can see once I go outside, I have pressure plates out here also now. In fact, that will be the only sign outside that I have a base at all, and they can be pretty easy to miss sometimes if you're in a hurry just going past. So if I step on these, you can see they also cause the doors to open like the set of plates on the inside did. Alright, now let's pretend we want yet another layer of security on top of what we already have. So here I've made this security lever, and when it's down it's disarmed, and when it's up it's armed. So in the disarmed state, I want to be able to still go in and out of the door like I would normally. So now I've connected all these pressure plates together, and I've connected all the pistons together. So in order for me to be able to step on these and open the door, it not only needs this signal coming in from the pressure plates, but also this signal from the lever. For instance, if I turn it off, then this torch will be on and the pistons will be powered and extended no matter what this other torch does. So it's basically ANDing this signal from the lever with this signal from the pressure plates, meaning both have to be active in order for it to open, the door to open. Now, I also have an armed state, so just for fun, what I wanted to do was not only will the door not open, but as you can see, there's a line out here that now this torch can be either powered by the pressure plates, and you can see that it is powered right now and the plates are not stepped on because of this torch acting as a NOT gate. So it takes the inverse of the pressure plates input as well as the inverse of the lever. It looks like the lever is powering this, but it's actually the feedback from this torch coming back upwards, because if I turn the lever on, you can see that this this redstone here becomes lighter. So as you can see, it needs both the power from the pressure plates and the lever to activate, and I've cut away this section of wall here to show that inside I've laid a trap, which is TNT connected to the lever inside and the pressure plates, so that when the system is armed and the plates are stepped on outside, it will actually wind up lighting up this TNT and it will blow up the dirt, and whoever's standing out there will be sent into the lava pit, hopefully. And as you can see, I've just cut away this wall, but normally this whole wall would still be there. So again, one more demonstration with the system disarmed, the lever down. I can come in from, I can go out from inside as normal. I can go back in, no problems. But if I then choose to arm it, and I'll show you this from outside, just fly up through here, and now I'm going to step on these plates and the TNT will go off. So I step on these plates and what's going on here? I don't know, what's nothing much going on, and boom, I'm in lava. See? And I have this giant torrent of lava that spawned naturally coming down. And in most survival modes, I'd probably be close to dead at that point. So, again, just depending on what I want to have done, that sort of determines the structure and the input and the output of your redstone, and what sort of gates and logic you need to use, and how even in Minecraft, math can really help you out and aid you in construction. So next time, on the next video, hopefully I will be able to show you some more redstone devices and some more advanced, well, not gates necessarily, but into a little bit more advanced as far as electronics go, such as devices like latches and flip-flops, which are still useful in Minecraft and a lot of fun to work with. So, until next time, this has been Andrew, aka Quick Brown Fox 42, and I hope you enjoyed the video. Oh, who's a good bunny? Who's a good bunny? Yes, you are, Fluffy. You're a good bunny. Daddy's gonna protect you from all those mean people with the redstone. He's gonna blow them all up. Oh, yes. Oh, kisses, 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 kisses.